All right, so for 4.1, we're graphing quadratics. And remember, quadratics is like all the stuff that we've been factoring on everything else that we're doing on all those other things. That for quadratics, the main thing is that we're graphing quadratics is that x squared is the highest power. Doesn't really matter what happens after that. But the main thing is that x squared is the highest power graph that we're looking at. All right, and this may come out of an equation. So you could have, if we look at just the basic, easiest one without doing anything to it, it could be y equals x squared if we're talking about an equation. And it could also be that we're doing a function. So it could be f of x equals x squared as a function. But, you know, those two things, for what we're doing graph-wise, they're interchangeable. It doesn't matter whether we're graphing the equation or the function. It's still the exact same thing when we're going through these. So it doesn't matter whether you start off with y equals or f of x equals. For what we're doing now, it's the same type of thing. And when we're going for this, for anything quadratics that we're doing, the basic shape that we're going to do is a parabola. Okay, and what we're going to do is we're going to do just a quick sketch of, you know, one of these equations. Technically, we're supposed to make some of these equations. They have you start off making like a T-chart. We're not really going to do that. We'll do just a quick one on the side just to make sure everybody has an idea of what we're looking at. So if this part of it, you don't have to write this part down, but if you just want to kind of watch. But if we were taking this equation, the y equals x squared, and we were going to plug in some values. If we plug in 0 into this equation, what is 0 squared? 0. Okay, it's no big deal. If we plug in 1, what is 1 squared? It's 1. If you plug in -1, what is -1 times -1? Still 1, right? So whether it's a negative or positive, we're okay. If you plug in 2, 2 squared is 4. If you plug in -2, -2 times -2 is also 4. So in people are like, well, is that always going to work out when you go through these? For quadratics, yes. If you once we get the middle of the graph basically on these, then everything else is going to kind of have the same answer whether we make it positive or negative. If we plug in 3, 3 squared would be 9. If you do -3 squared, it would also be 9. So we can keep going down the list to go through these. If we graph this one, now we're not going to do the 3s because that gets a little bit too far off the graph for what we're doing. So we're just going to graph these first 5 points we have here. But if we graph 0, 0, that would put us here. If we graph 1, 1, that would put us here. If we graph -1, 1, that would put us here. If we graph 2, 1, 2, 3, 4, it would put us up here. If we graph -2, 4, 1, 2, 3, 4, that would put us over here. Okay, and then we connect the dots and put it all together. So we get a graph that would look something kind of like that. Okay, and that's the parabola shape. Now, again, it could be that it's like this one where the graph opens up or the arrow points up. It also could be like the St. Louis Arch, you know, where it's pointed down like this, you know, anchored this way. So either way you go, it doesn't matter. As long as it's got that U-shaped curve to it, that's the parabola shape that we're looking for. And as long as x squared is our highest power, every graph will look something like that. Now, it may be a little narrower, a little wider. It may be shifted up and down and left and right, but they're all going to have that same basic shape when it comes off of it. Okay, so here's all the details we need to get on these things. Here's all the stuff that we got to get when we pull these things out. When we talk about a graph like this, there's the most important point on here is the vertex. And the vertex is either the top or the bottom point of the graph. That's also like the midpoint of the graph. So the vertex, now again, depending on which way we go. If we do a graph like this, it's the bottom point. If we had a graph like this, it would be the top point. But it's either the top, depending on which way the curve goes, it's the top or the bottom point of a quadratic. It is the most important point that's on here because it's the midpoint of the graph. If we want to kind of think about it that way. Because here's what it is. Once we find out where the vertex is, like for this equation back here, the vertex would have been at 0, 0. That once you find the middle of the graph for this one, once you find the vertex, then it's basically going to be the same that every point after that. If you move one space to the right or one space to the left, these two values will always be the same. Whether you move 2 spaces to the right or 2 spaces to the left, these values will always be the same. You know, if we move 3 spaces to the left or 3 spaces to the right, this value will always be the same. So once you get the vertex, it doesn't matter whether you go to the right or to the left, everything's going to be equally spaced out. And that's kind of what this thing is kind of saying, that if we go one space this way or one space this way, it's the same distance apart here when we go for this part of it. Okay, and that's kind of the next thing we're talking about here, which is the axis of symmetry. And the axis of symmetry, what we're going to do, sometimes on this one, we'll just, to make it quick and short, when we talk about this on some of the notes and things we do, we may just call it the AOS for axis of symmetry, just to make it short. That's just a vertical line that is drawn through the vertex. Drawn through the vertex. Okay, and again, because the vertex is the midpoint of the graph, the axis of symmetry it's basically it's a line of symmetry. What it is, it's so the right side of the graph should now be same as the left side of the graph. The equation for the axis of symmetry. Again, we'll just do the AOS for short here. So the equation for the axis of symmetry is always going to be the exact same thing for no matter what we do on these. It's always going to be x equals the x value of the vertex. Okay, so the vertex is the point that's in the middle of the graph. Basically, the axis of symmetry is a line that you draw that would put it in the middle of the graph. Now, for this problem up here, if we go back and draw the axis of symmetry, most of the time when you're doing these in the homework, they're going to ask for it to be a dashed line. And I'll come back down in just a second. If you draw this line, you're not going to see it because it's right on top of the y-axis. But it's one of those things where if we scoot it to the right or the left a little bit, it would be real obvious to see it here. We'll do that on some examples coming up here in just a minute. But that's kind of what we're looking at. So the vertex, that is the most important point because that's the middle of the graph. It's either going to be at the top or the bottom of this quadratic graph that we have. And again, the axis of symmetry is where you draw a line through the vertex that cuts it into equal halves. Okay. And then we're going to come back and do some stuff with domain and range here in just a little bit. But we'll talk about that one. So to graph these, so the graphic quadratic that is in vertex form, we're going to do two things. And this is really pretty straightforward. This is not very complicated when it comes off of it. The first thing you're going to do is you're going to plot the vertex. All right. Now, and when you do that, you've got the vertex for what we need. Because again, the vertex is the most important point. So once we've got that, everything else is going to spin off this one. Second thing we're going to do is you need one more point. Now back here, if we go back real quick, once we had the vertex here, we had like 7 or 8 more points on this one because we plugged points in. We're not going to go through the process and plug in all these values, but we do need to plug in one more value. So the easiest thing to do is we're going to find the value of one more point on the graph. So find the value of at least one more point and plot it. And the good thing is with the Math Excel, the way it does, as soon as you plot one more point, it will automatically draw and adjust this graph for you. So you don't have to worry about, 5 or 6 or 7 points or anything along those lines. That basically once you've got the point that's here, then everything else would be good. All right, now here's what we're going to do, and kind of going through this one. In most cases, usually the easiest thing to do when you're finding this next point here, and it's not always, I'm going to show you one here in a little bit where we can actually do a shortcut. Usually the easiest point is the next whole number, or we'll just say the next value beside the vertex. And we'll say, now when we're talking about this, when we're talking about the x values, so usually the easiest point is the next, I wouldn't even say integer value. It's the next whole number value that's beside the vertex's x value. You can either go to the right side or you can go to the left side of it. So once you find that next x value, you got to plug in the x value. So we're going to use that x value to evaluate. Okay, and again, evaluate just means we're going to take that number that we have here and just plug it back into the equation and work it out. All right, now here's, and when we actually graph one here in a little bit, I'm going to show you that one, but I'm also going to show you a shortcut that we can do, because in most problems that we have, there might be one or two that maybe is not this way. There's a shortcut that we can do that will make this thing go quicker than what it is that they're going to ask us to do for this part of it. Okay. All right, so here we go. Here's where we're going to get a couple more things off this one, get a couple of the main things we need, get all the details here, and then we go back and graph it so we can kind of see everything that's going to happen with it. It's y equals, now again, it could be y equals or it could be f of x equals. It's a times x minus h squared plus k. All right, but here's what all that means. Now, obviously, the x's and the y's are like your ordered pair kind of thing for this one. But here's the big thing that you need to know off all this stuff. The a value determines the direction of the graph. So for me, this one is kind of like slope. It's not exactly slope, and we'll get into more detail on this in just a second. But it's kind of like slope. So it's kind of sort of like slope. The h value and the k value, you pull those two numbers out to get your vertex. So if you want to think about it this way, h is like your horizontal movement. That's where the h part of it comes from. And k is, it seemed like to me it should be v for vertical, but k is like your vertical movement. And maybe we borrowed that from a different language, but to me, it'd make more sense if it was h and v. H would be your horizontal, v would be your vertical, but in this case, it's like h and k for this part. All right, now, and the thing that some people are asking when we're doing this sometimes, they're like, well, this was x minus h, and this is a positive h here. Whatever the sign is that's here, you're always going to change this sign from negative to positive, or if this was a positive h, then you would change this to a negative h. So whatever the sign is that's here in the parentheses, you always wind up changing that sign when you take it out to figure out what the vertex is. What the a is for this part of it, we're going to say that the a value determines the direction of the graph. And basically is this. So A is going to determine the direction of the graph. So again, it's kind of like slope, but it's not really slope. It's a little bit different than that. That if A is positive, the graph, they say, opens up. Now, this is not the technical term, but most people think about it this way, that the arrows point up. So that was basically this first graph that we had back here we did in the beginning. That this would be one where the graph opens up, because again, if we keep drawing this thing, the arrows are pointing in the up direction. So that's kind of the connection you want to make. That if the a value is positive, the graph opens up, you're going to have a graph that looks something like this. All right, now here's the thing you have to kind of catch with this one. If you do a graph like this, okay, the vertex would be at the bottom. And if the vertex is at the bottom, they're going to say that that's going to be a minimum point. Now, for what we're going to do, most of the time, we're just going to make it short and easy. We're going to say max or min. But a lot of times in the homework, they'll have maximum or they'll have minimum in this thing. So the big thing is, if A is positive, you just draw a quick sketch of the graph. The vertex is at the bottom. And if the vertex is at the bottom, that means it's a minimum point, because that's the lowest value you can get on this graph. All right, here's what you can kind of tie in with the other things on this one. For any problem that we do on this one, your range, because they're going to talk about domain and range. So for a problem like this, the domain is all real numbers. And here's where you're going to have to talk about the range a little bit. And this is where it gets easy if you know what the a value is. The arrows are pointing up, correct? So which way is up, greater or less than? Up is greater, right? So when I talk about the range on this one, your range is going to be y greater than equal to your y value of your vertex. Okay, so way back here, we knew that the axis of symmetry was going to be the h value from back here for whatever the vertex was. The k value, that's either the maximum value or it's the minimum value for whatever it is that you're doing. And again, if the arrows are going up, that means the y values keep going. So the y values keep going up, so the y values are greater than. And then if we do the opposite on this thing, if a is negative, then the graph, it feels funny to say that it opens downward, but that's technically the correct math term, that it opens downward. Again, for what we're doing, okay, so if a is negative, the graph opens downward. Again, basically it points down. All right, and with that, there's going to be a bunch of different things we can do with that. That means the vertex is at the top. because now you've got a graph that looks something kind of like this. So if we graph that part of it where it's pointed, opens downward, or it points down, that puts the vertex at the top, which means it's a maximum point. Okay, and with that, again, there's a lot of information that goes on with just where the vertex is and all the stuff that goes with this one. The domain for any of these problems that we do is always all real numbers. So that part is never going to change. Because again, these are your x values that you're going to do. The range is your y values. But again, if you think about the direction in this case, the arrows are pointed down. And if something is going down, it's getting smaller. So that means it should be less than or equal to than the y value of the vertex. Okay, so this is one of those things where with just a couple of pieces of information, there's a lot of stuff that's in this. So the a value tells you the direction of the graph, which also tells you then if the vertex is going to be a maximum or a minimum. And then based on whether it's a maximum or a minimum, if you just got the basic shape of the graphs, the domain will be all real numbers. And then the range is either going to be, if it's pointed up, it's going to be y greater than this number, or it's going to be y less than this number, depending on the direction the graph is going to go. So one or two little numbers tells you a bunch of different things when it comes off this graph for everything that we're going to do. All right, so here's what we're going to do. That's all the details. That's everything we've got. We're going to run through a few examples, do everything that we can possibly do with this one, and show you all the parts and pieces of it. Put all this thing together so we've got all kind of different examples so you can see everything that's going to happen here. All right, so here we go. So let's go with that. We're going to find the vertex, the axis of symmetry, either the max or min values, and the domain range. And then we're also going to graph it. So first example we're going to do y equals x minus 2 squared plus 3. All right, and sorry, too far. And the good thing on this one is, again, all the information that you need is right here. You don't have to do anything to the equation. You just basically go back in and pull out the numbers. So the a value would be the number that's in front. Well, if there's not a number here, it's understood to be a 1, because it's basically that there's, if you don't have a number here, you can almost think about a 1 being here, that this could be like distributed property with a 1. So it's almost like there's a 1 with the x on that part. So it's always going to be an understood value of 1 for this thing if there's nothing there. Okay, to get the h and the k, the h is always the inside number, the k is always the outside number. And then for this one, what we're going to do is we're going to change the sign from -2 to a +2. This number will always stay the same, so it's going to be at 2, 3, and that's our vertex. Okay, so we've got the vertex. The axis, once you get the vertex, now you have the axis of symmetry, because the axis of symmetry is going to be x equals, it's just the x number. So it's x equals 2, because you're going to use the same number you get here, which is the number on the inside, change the sign. It's the same thing for the axis of symmetry. So now the axis of symmetry is done. Okay, the max, the min, the domain, the range, all of this stuff, we can kind of get that off of this one, because as soon as you know that the a value is 1, which is positive, take 2 seconds and draw the basic shape of it, because we know the graph has to do this, because this is a positive 1. As long as it's positive, the graph has to do that. Has to, no matter what we do. And from that part, we know the vertex is going to be at the bottom, which means this thing has to be a minimum. So now we know what the max or the minimum is. And to get the minimum value, now that's the y number. So the minimum value would be 3. So once you've got the vertex, it tells you two things. It tells you the x value is the axis of symmetry. The y value tells you whether that's the max or the min number, and you know if it's max or min based on the shape of the graph that you have here. Okay, and then we can use all that stuff to get the domain and range, and then we'll finally get to the graph. So the domain, that's always all real numbers, no matter what we do. Any graph that's a quadratic, the domain will always be all real numbers. I think sometimes on this one they may show that like x goes from negative infinity to positive infinity, something like that. The range, again, this is where you can just look at the values. The arrows are going up. Up is greater. So the range is going to be y greater than or equal to whatever this value was. It was right here with the y value. So it's just y greater than or equal to 3. Okay, and some people go, well, that's a lot of stuff. Yeah, but that's a lot of stuff and that's all given to you. Everything is there that's in front of you. You just got to look at it and pull out all the parts and pieces on it. We didn't have to do anything fancy to this thing. The fanciest thing you had to do was change this from a -2 to a +2. Okay, and graph-wise, here we go. So if this graph is at 2, 3, you don't need a lot to the left and you don't need a lot to the bottom. So we need this to have kind of a lot of room kind of topping right here. So we're all up in this area. All right, so the most important point is the vertex. If you don't get the vertex correct, then there's really not much else you can do that's going to make this graph be what it needs to be. So go to 2, 3, and we'll put a point right there. Okay, now what we do know is we know the graph is going to go something like this. This is where you have to get the details. You've got to get at least one more point using Math Excel to make everything kind of fit in. The easiest point is to get the next point right beside it, which would be 3. Now, here's where we're going to do a shortcut, though. As long as this a value is a whole number, here's where we're going to make it kind of like slope. We're going to put this thing as like 1/1. To get the next point to the right or the left, we're going to go up 1 and over 1 to the right. We can also go up 1 and back 1 to the left, and that will kind of get us there. So we're going to use the a value as a shortcut as long as it's a whole number. Now, that only gets the next point. It doesn't get every other point after that, because after that, this thing starts to curve and go really fast. So once we get here, this thing takes off in a hurry. It's no longer an up 1 over 1. Now it's more like it's up 4 and over 1, or, you know, it changes from there. But to get the next point, which is enough for what we're going to do on Math Excel, that gets us here. Technically, we're supposed to go back and, you know, plug in all these numbers kind of like we did back here. But we're just making this thing quick, so we don't have to go back and plug in all these numbers. We're just making it so we've got at least one to get us going, and then we'll kind of rough sketch this thing out from here. All right, if they ask you to draw an axis of symmetry, that's where you go back and draw a dashed line right down the middle, and that would be your axis of symmetry. That one you can see it because it's not on top of the y-axis, but that's kind of the spot we're going for there. Okay. All right, so now so that's the basic one where we've got everything that we need. Let's show you some where we do just all kinds of different things so you can see the different things that might happen to you as you're graphing some of these. All right, so for example, 2, this time we'll do a function, so it's f of x equals, and we'll do x plus 4 squared. Okay, we'll still do all those things that we were doing before. All right, so the a value is 1, which, again, if you want to sketch it real quick, you know, it's got to do something like that. Puts the vertex at the bottom. If it's at the bottom, it's a minimum. Okay, now here's where some people get a little off on this one. Your h value, that's what's on the inside. Again, we got to change it from a +4 to a -4. There's nothing on the outside, right? So what's the same thing as adding nothing? If you're adding nothing, that number would be 0. So if there's nothing on the outside to add or subtract, then that default goes to 0. You're like, well, how's that first number 1 and the last number 0? Because again, in the front, you're multiplying. So the only way to make it so this doesn't change is you multiply by 1, because you're multiplying 1 times this number. On the end, you're adding something, and to add something that doesn't change anything, you'd have to add 0. So, yeah. Okay, so now you've got everything you need. There's your vertex. Again, your axis of symmetry is going to be x equals -4. In this case, our minimum value is going to be the y value here, so that's going to be y equals 0. So the x value is the axis of symmetry. The y value is either the max or min value, and we know if it's max or min based on what the graph is based off the a value. All right, now, and again, you could kind of go ahead and do domain and range here if you want to. Domain. All right, here's the shortcut if you just want to say all reals. All real numbers. We got that. There's actually even a shortcut you can do. It's like a double-legged R. That's the shortcut for all real numbers. Now, you won't see that in anything we do in the homework, but that's just a shortcut notation if we ever need to talk about it. The range. Again, think about the arrows. This is going up. If the arrows are going up, that means it's greater. So it's y greater than or equal to whatever the y value was that was here. So that's going to be y greater than or equal to 0. So the x value here is for the axis of symmetry. The y value here tells you the max or the min value, which is also the part of the range. Okay, so once you've got those things, once you've got the a value and the vertex, you've got basically everything they're going to ask you to do for this thing. Now we're just going to go back in and graph this one. I think we can actually get this graph right here, because this graph is more wide side to side than it is up and down. Because the vertex is at -4, 0. So that's 1, 2, 3, 4. So if we go to -4, 0, that would put us here. All right, and again, the a value is 1. And again, this is where we can cheat a little bit. So if you're okay with cheating on this one, as long as this is a whole number, we'll put this over 1. To get to the next number on the graph, we're going to go up 1 and over 1 to the right side. Then we're going to go up 1 and over 1 to the left side. And then again, as soon as you do that in Math Excel, it's going to go back in and graph this thing for you. So you can see the graph run off like this. Okay, now, again, you don't have to write this down. But technically, here's what you're supposed to do. You're supposed to pick the next number to the right side. Or you can pick any number. You can pick -3 or -2 or -1 or -5. You can go all the way up here. But usually the easiest number to plug in is -3, because you pick the number that's right beside your x value here. So whether you pick -3 or -5, it doesn't matter. If you pick the number to the right side, you make this answer positive, which most people would rather do. And then you plug that thing in, and then you work it out. So when you plug in -3, the answer you get is the y value. So that's going to give you an ordered pair that's at -3, 1. So if you go back and check it, it's -3, 1, and that's the point that you have right there. So that's technically what we're supposed to do, but we're going to take some shortcuts just because we're going to cheat a little bit if we can. All right, let's give you one where the a value is not 1, so we can kind of see what happens there. So let's go with 3x squared minus 2. All right, so whatever's in front of x squared, that is your a value. So a value is 3. Again, it's still positive. So we know we're still doing this. Vertex is at the bottom. We know it's going to be a minimum. Okay, and again, you can get all that information just from the a value. That's all you need. When you get to the vertex, and sometimes people get thrown off on this one because they're like, wait a minute, we don't have a parentheses. If you don't have a parentheses, if we're going to get the h and the k that's here, If you have no parentheses, yeah, then the h is automatically 0. So no parentheses, then the default value for h is 0. Now, if you have something after that, anything after that, there's no parentheses, the number that's there behind x squared, that would be your k value. So for this one, 0 is going to be there. Our k value is going to be -2. And that's going to be a vertex. All right, so no parentheses. You say, all right, no parentheses, no problem. That just means the h value is going to be 0 because we're not adding anything on the inside of the parentheses. If there's another number behind it without the parentheses, that's automatically the k value. So there's our vertex. Our axis of symmetry is x equals 0. So that's our axis of symmetry. And again, the max or min value is going to be the y value that's here. That's at -2. Okay, and again, we can use that to help us get the range. And again, the range is, well, which way the number is going. Well, the arrows are pointed up, so that means that the numbers are going up. So it's y greater than or equal to the y value that you have right here. And if it asks for a domain, that's all the real numbers. And we'll do the shortcut here. It's a double-legged R. Okay, now the good news is they're not going to ask all this stuff on every single question. There may be one or two where they may ask you to do like everything, but a lot of times they're just going to ask for like the vertex and the axis of symmetry, or they may ask you just for this piece. So not every question they're going to ask you everything, but we're going to go ahead and just get everything out here. Okay, so graphing this one. Let's see, the vertex is at 0, -2, so that means it's got to be more towards the bottom. So basically just make it just a regular graph because it's going to be kind of equidistant up and down when we go through this one. All right, so vertex is at 0, -2. So we're going down 2, and we're going to put a dot right there. All right, we do know the graph is going to be going up, so we know it's going in this direction. And again, as long as the a value is positive, we're going to do a shortcut. We're going to put it over 1, and that gets us to the next point. Now, again, it doesn't get us anything other than the next point, but for Math Excel, that'll get us the graph on this one. So from here, we're going to go up 1, 2, 3, and over 1. You can also go up 1, 2, 3, and over 1 to the left and get either one of those 2 points. It doesn't matter. And then we'll just draw this thing in and connect the graph to get what we're looking for. Okay. And again, if we drew the axis of symmetry, you won't see it because it would be right on top of the x-axis, and it'd be something like that, so it's kind of hidden there. That's a problem where they probably wouldn't ask you to draw it because you may not really be able to see it there. All right, we do need a negative because we haven't done a negative yet. So let's get you a negative, and then I'll show you the one problem that we don't get to use the shortcut of doing this to kind of get our graph drawn. We'll have to do something else. All right, so we've got -2 times x plus 1 squared minus 3. All right, so getting the basics out. We've got our a value is -2. First time we've had a negative, so now instead of pointing up, it's going down. And again, if that one's going down, the vertex is at the top. That means it's a maximum point. All right, so here's our h and our k values. So our vertex is going to be, and again, change the inside value, or whatever's on the inside of the parentheses, you always have to change that sign. The number on the outside, it stays the same. All right, and our axis of symmetry is the x value. The y value is your max or your min. In this case, that's a max point, so -3 is our max value. Okay, and again, I know it's a lot of information, but the thing is just, you didn't have to do anything. You just had to pull the numbers out to make sure that you know what it was. So there's a lot of information off of this one thing to get all the stuff we're looking at. And again, if you know what the graph is, we can also go ahead and get domain and range. Because the domain is all real numbers every single time. So that part won't ever change. And a lot of times, some of the questions, they want to ask you about the domain because you know it's going to be all real numbers every time. The only thing they may really worry about is the range. In this case, the arrows are going down. So that means we need y to be less than or equal to whatever this y value was that was here. All right, and finally, we get to graph this thing. This one, we need a lot of room to the left and down. So when we're graphing this one, maybe it'll fit in here. It's going to be pretty tight. Need at least 3 or 4 spaces down. We'll get it in as best as we can. So hopefully we'll be all right. We'll get as much as we can on that spot. We got 4 to the left and 4 down. That should get us most of the basic information we need there. Okay. Vertex at -1, -3. 1, 2, 3. So that's going to get us right there. Barely going to get it in. All right. So it's -2. But again, we'll use a shortcut here. To get to the next point, we're going to go down 2 over 1. So down 2 over 1 would put us right there. Down 2 over 1 would put us over here. So just barely going to get this thing in, but we'd have a graph that would go off and do something like that. All right, and again, if you had to draw the axis of symmetry, you can go back and draw a dashed line through it, something like that. Okay, and again, I wish we'd had like 1 or 2 more lines, but kind of ran out of room there. All right, last problem of the day. This is the one that, I got to show you one where you cannot use this cheat that we're going to use here, where it's whole number. So we've got to give you one that's a fraction. All right, last one of the day. And for this one, we may not do near as much stuff as we did on all the parts. We'll just make sure we get it so we can graph it. So we'll do 1/2 times. Let's do x minus 3 squared plus 1. Okay, so the a is 1/2. The vertex would be at 3, 1. All right, now we're not going to worry about everything else because everything else was exactly the same. Getting the domain and the range and everything else was going to be okay. We do know this thing's going to be going up, so we're going to come back and graph this one. So this is at 3, 1. So we need a lot of room over here to the right side of it. Need something like that. Okay, so vertex at 3, 1. We'll go over 3 and up 1. All right, now here's why this doesn't work if we pick something other than 1. Anytime we pick the next number right beside it, this answer would always be 1. If we did 1 squared, that was going to get us 1, so it always worked out. But this one, we're going to take that answer and multiply by 1/2. So if we try to go back and do the up 1 over 2 thing on this part, it's not going to give us the correct answer. So you have to pick another number besides just doing the shortcut on this thing, because you cannot do the shortcut with the 1/2. It won't give us the correct answer. Here's what we've got to do. And because of this, okay, we're going to get a fraction answer on this, right? If we pick, and I'll show you this one, and don't write this down, but just kind of watch. If we pick the next number right beside 3, that would be 4. There's a small problem if we pick 4. If we plug in 4 for x, we get a half of 1 squared plus 1. That's a half of 1, which is just a half. And you do a half plus 1, that comes out to be 1.5. It's going to be hard to graph 1.5 if we pick the next number right beside it. So if we plug in 4, we get 1.5. That's our y value. So that means this is going to be like right there. And you're probably not going to get a chance to graph that one on the homework. So here's what you have to do. You have to pick it so that when you get a number here that's going to come out that we can divide it by 2. So the best thing to do is to make it so that when you plug in a number that's here, when you plug in an answer, you're going to get a multiple of 2. You're going to get 2, or you're going to get 4. You're going to get some even number that you can go back and divide it by 2. So for that one, if you plug in 4, 4 minus 3 is 1. You're going to divide that in half. You're not going to get that. So probably the best thing to do is just to pick a number that this will come out to be an even answer, which means probably the easiest thing to do would be to use x equals 5. Because if we plug in 5, that's 5 minus 3 squared plus 1. 5 minus 3 is 2. 2 squared is 4. Half of 4 is 2, and then 2 plus 1 is 3. So to get an answer that gives us a whole number, we had to go over so that this thing came out to be an answer of 2, because then that way these 2's get to cancel out when we go back to the part back here. So this would be at 5. We'd have to go up to 1, 2, 3 to get the next point here. So if we go 2 spaces to the right, we've got to go up 3. Same thing here. If we go over 2 spaces, we've got to go up 1, 2, 3 and put a point right there. And that would get you the points that we need to go back and get this thing out. So if this is a value, if it's a fraction, you cannot use our cheat shortcut that we try to do to get the next point. You have to do something. So here's what you want to kind of do. If this fraction had been a third of something, you want this answer in here to come out to be 3. So that these two things would kind of cancel out. If this number was a fourth, you want this answer to come out to be more than likely 4. So that you always go back and cancel it out. So that's kind of what you have to look for on those with fractions, that you want this inside number to basically match up to this so that eventually they'll go back and cancel each other out.